This lesson is on other angles as they relate to circles. The essential question for this lesson is, what are the relationships among the arcs of a circle and the angles formed by chords, secants, and tangents? During this lesson, we are going to learn about two additional theorems. The first of these will be Theorem 9-9. This theorem states the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. For example, let's say we've got a circle and we have two chords AB and CD, and they intersect at point E. So what exactly is this theorem saying? This theorem is saying that the measure of angle DEB, which is going to be this angle right here, is equal to 1/2 the measure of arc AC over here plus the measure of arc BD, which is over here. So the measure of angle DEB is equal to 1/2 the measure of the sum of the arc AC plus the measure of arc BD. The next theorem in this lesson is Theorem 9-10. This theorem states the measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside a circle is equal to half the difference of the measures of the intersected arcs. Now, with this particular theorem, there are three cases, as you can see from the wording. So let's deal with each case separately. So let's say we've got two secants. So we've got a secant ABD and another secant ACE, and they're intersecting the circle from a point outside the circle. So what is exactly is this theorem stating? It says, if you've got two secants, as shown in the picture here, the measure of this angle, and it'll be angle A, is equal to 1/2 the difference of the intercepted arcs. The major arc, or the larger arc, being DE, and the smaller arc being BE. So therefore, the measure of angle A is equal to 1/2 the difference of arc DE minus arc BC. So the next case, case 2, is when we have two tangents. So as you can see in the picture, we have two tangents. One of them is AB, the other is CB. And what this theorem is stating is that the measure of this angle out here, specifically angle X, is equal to 1/2 the difference of angle ADC minus arc, the measure of arc BAC. So the measure of angle X is equal to 1/2 the difference of the measure of arc ADC minus the measure of arc AC. So the third and final case is when we have a secant and a tangent. So as you can see in the diagram, we have a secant UXY and a tangent UV. And what does this theorem state about that? It basically states that the measure of this angle out here, angle U, is equal to 1/2 the difference of arc VY minus arc VX. Okay? So the measure of angle U is equal to 1/2 the measure of arc VY minus arc VX.